Good morning students. In our last class we have studied about types of relation. Today we will discuss about types of functions. Before studying about types of function, let us recall what we have studied about function in our previous class. So what was function? We have studied that when we will call a relation a function. So let us say A and B are two sets. Then we have said that every element, let us say there are three elements in set A. So we said that each element in A must have image. So let me write some element there. Let us suppose there are four elements of this type. So each and every element in A must have some image. Let us say this. So one condition was each element in A must have image, and the second was image. Each element in A must have one and only one image. So we cannot do like this, that A is going to this element also, one is going to this element also, and one is also going to this element. It means that one has two images, which is not possible. If this will be there, so this will not be a function. So for a relation to be a function, each element in set A must have one and only one image, and domain of function must be A. So if this is a function from A to B. So this is what we had studied in our previous class. So this will be clear to you. So today we will discuss about types of function. So in types of function, but first we will study about one-one function. So what is one-one function? A function f from x to y is said to be 1-1 or injective. We can also call it injective if the images of the distinct elements of x under f are distinct. So what we are saying, that we are saying images of distinct elements of x under f are distinct. Means if this is a function from x to y, and let us suppose there are three elements, and here are also three elements, let us say four elements. So let us suppose this has image this also has image this has image this will not be one function. Why? Because two elements are having same image. This is a function but not one function, because two different elements have same image. So what will be one function? One function means if there are four elements in this set, each must have different image. So if this is the image of this one, so this cannot be image of this one now. So it can be like this. So here in this function, each element in x has distinct image. So two elements in x cannot have same image. So when we will prove it for the questions, how we will do, what does it mean? That means for every x1 x2 belongs to x, x1 f of x1 is equals to f of x2 implies x1 is equals to x2. What does this mean? It means that if two images are equal, this will imply that three images are also equal. See, let me show you what this definition is saying. See, if this is one set and this is another set, and we have defined a function from set x to set y, and let this be x1 and this be x2. So what we are saying, if f of x1 is equals to f of x2, so let us see f of x1. So what does this mean? This is a function from x to y, and image of x1 under this function is, let us see this, and image of this is also this, because we are saying the images are equal. So if the images will be equal, this will imply that points are also equal. It means if images of these are equal, so these points cannot be distinct. This should be also equal, so this should be the one point. This, if this will be equal, it means this is a one point. So what does it mean? Whenever the images will be equal, the points will also be equal. So what does it mean? It means that one element can have only one image. This is what we have studied about the one function, that only one, each element, images of the distinct elements of X under F are distinct. So I think this will be clear to you. Let us take some more examples. Let us say there are four elements, 1, 2, 3, 4, and let here be A, B, and C. And this is a function from X to Y. F is a function from X to Y. So now let image of 1 is B, image of 3 is A, image of 4 is C. So 2 must also have some image, otherwise this will not be a function. We have said that for a relation to be a function, each element in this set, in X set, must have image. So let us say 2 has image B. So in this case, this function will not be a function. Why this will not be a function? Because 1 and 2, there are two elements which have the same image. So therefore this cannot be 1 function. So for 1 function, every element in X must have distinct image. So I think this will be clear now. Let us go to next. Next is a function f from X to Y is said to be onto or surjective if every element of Y is the image of some element of X under F. So what are we saying here? We are saying, let us say this is a set X and this is a set Y, and we have defined a function f from X to Y. Then for a function to be onto, let us say there are three elements, and let us say here are two elements. So what does it mean? This means for function to be a one-to, each element in set Y must have a pre-image. So let us say 1 is mapping to 1, 2 is mapping to 2, and 3 is mapping to, let us take 3 here. So in this case, all the elements in Y have some pre-image, right? So this function will be onto function. Let me take one more example. Let us say here are three elements, 1, 2, 3, and here are only two elements. Let A and B. So let us say these are the images. So let's say this is X set and this is Y set, and we have defined this function f from X to Y. So will this be onto? Let us check. What we have said, for every element in Y there must have pre-images. So A has pre-images, yes, 1 and 2 both are pre-images of A. B has pre-image, yes, 3 is the pre-image of B. So this function is onto. So now let me take an example in which function is not onto. So let us take, there are three elements, and here we have four elements. Let us say this is set X and this is set Y, and we have defined a function f from X to Y such that image of 1 is 2, image of 2 is 1, image of 3 is, let us say 4. So is this function onto? No, this function is not onto. Why? Because there is an element 3 in y which does not have any pre-image. It doesn't have any pre-image. Therefore, this function is not onto. So, for function to be onto, each element in y must have some pre-image in x. So, if we will show it, then what we will do, what does it mean? That is, for every y belongs to y. So what does it mean? For every y belongs to y, for every element here, this is x and this is y. So we are saying for every y belongs to y. So for every element here, there exists an element x in x such that f of x is equals to y. So for every element here, there must be an x. For every y, if this is y, so for every y there will be some x. Each element will have some pre-image such that when we will apply the function on this x, we will get what? Image of this. So when we will apply the function on x, what we will get? We will get the image of that element. So basically what does it mean? It means is for every element in y there must have a pre-image, or we can say for every element y belongs to y there must have an x in x such that image of that x is that y. I think this will be clear to you. If you have any doubt, then you can ask me. Next one is a function f from x to y is said to be 1, 1 and onto or bijective. So if function is both 1, 1 and onto, we will say this function is bijective. If f is both 1, 1 and onto, so when we will say the function is bijective, and this will be both 1, 1 and onto. So now let me take some examples. Let us say this is set x and this is set y, and here are some elements 1, 2, 3, and here are some elements 1, 2, 3, 4. So let us say 1 is mapping to 1, 2 has image 3, 3 has image 2. So we have to check about 1, 1 and onto. So we will check for 1, 1. So what we have said for the 1, 1? For 1, 1, each element in x must have distinct image. So 1 has image 1, okay, 2 has image 3, okay, 3 has image 2. So yes, all the elements have distinct image, so this function is 1, 1. Now let us check for the onto. What we said for onto each element in y must have some pre-image. So 1 has pre-image, yes, 1 is the pre-image. 2 has pre-image, yes, 2. 3 is the pre-image of 2. 3 has pre-image, yes, 2 is the pre-image of 3, but 4 has no any pre-image. We don't have any element in x such that f of x is equals to 4, right? So we don't have any element here which is the pre-image of 4. So therefore this function is not onto. So if it is not onto, then we can't say this function is bijective, because for function to be bijective it must be both 1, 1 and onto. So now let us take one more example. This is x and this is y, and let us say there are 4 elements and there are 3 elements. Let us say this function 1 is mapping to 2, 2 is mapping to 1, 3 is mapping to 2, 4 is mapping to 3. Now let us check about this. We will check about 1, 1. So each element must have distinct image. So 1 has image 2, 2 has image 1, 3 has image 2. It means 1 and 2 both have same images. 1 and 3 both have same image, and that is 2. So this function is not 1, 1. And what about onto? 1 has pre-image, yes, 1 has pre-image, that is 2. 2 has pre-image, yes, it has 2 pre-images, 1 and 3. 3 has pre-image, yes, 4 is the pre-image. So this function is onto but not 1, 1. So again this will not be bijective function. Why? Because this is onto but not 1, 1. So let us take some more examples. Let us say this is set x and this is set y. So f is a function from x to y, and let us say there are 4 elements in this set, and there are again let us say 4 elements in this set. Let us say image of 1 is 3, image of 2 is 1, image of 3 is 2, and image of 4 is 4. Now let us say, is this function, let us check, is this function 1 1? 1 has image 3, okay, 2 has image 1, 3 has image 2, and 4 has image 4. It means each element has distinct image. So what does it mean? This function is 1 1, yes. Now let us check about onto. 1 has pre-image, yes, 1 has pre-image, that is 2. 2 has pre-image, yes, 3 is the pre-image of 2. 3 has pre-image, yes, 3 has pre-image 1. 4 has pre-image, yes, 4 is the pre-image of 4. So this function is both 1 1 and onto. So this type of function is bijective function. So we will say this function is bijective function. So I think this will be clear to you now, that if a function is both 1 1 and onto, then function will be bijective function. Let us go to next slide. Now let us see some example. Let A be the set of all roll number or 50 students of class X in a school. So what is a set? Set is 50 students of class X. Let f is a function from A to n. A to n, what is A? A is set of 50 students of class X. So what we have defined? We have defined a function. We have defined a function from the set of 50 students to n. N is what? N is set of natural numbers. And how we have defined a function? Function is defined as f of x is equals to roll number of the student x. So how we have defined function? Roll number of the student x. So here we have 50 students, and in this case we have roll number. So let us say 1 2 3 and so on. So obviously each student must have some roll number, right? So what do we have to show? That this function is 1 1. So what do we know? For function to be 1 1, each element in A must have distinct image. So each student in A must have distinct roll number. No two student cannot have same roll number. So yes, this function is 1 1. What about onto? So we have 50 students only, right? So we have 50 students, then they will have roll number from 1 to 50, but natural number contains so many elements in it, right? So let us take about 51. There is no any, wait a minute,